In this video, we'll look at merging of two linked lists. If you look into the section arrays, there we have seen how to merge two arrays. Now we are learning how to merge two linked lists. So let me tell you briefly about merge process. Merging is a process of combining two sorted lists into a single sorted list. So I have two sorted lists. First linked list is sorted 2, 8, 10, 15. Second is also sorted 4, 7, 12, 14. Both are sorted. So combine them. We will combine these two into a single sorted list. The next thing, if you remember, merging two arrays, you require one more third array. But in linked list, it's not necessary. If you want, you can take third linked list. Otherwise, you can combine these two and make it as a single linked list, one single linked list. You don't need extra linked list. I'll explain you the procedure how merging is done over linked list, and also simultaneously I may write down the program code also. So let us see. This is first linked list, this is second linked list. For merging, we require one more pointer. Let us call it as a third. I will take one pointer called third, pointer third. And for helping that pointer, I will take one more pointer, that is last. I need two pointers. One is a third, that will be pointing on the first node of third linked list, that is merged linked list. And also I will use one more pointer called last. This will be pointing on the last node of that merged linked list. So I have to use two pointers. Let us start the procedure. What is the procedure? Compare the element of first node in first linked list and element of first node in second linked list. Which one is smaller? This is smaller. When this is smaller, bring last as well as third upon this node. We'll bring third as well as last on this node. Because this is the first node, we are starting from here. So make it point on that one. Then move first to next node. First will move to next node. I'll just write F instead of first. Then make this as null. So now you can see that the first linked list is having only 3 nodes and this is the first node. Then what about the previous node that was already there in the linked list? Now it belongs to merged linked list where both third and last are pointing there. In the first step, we have to bring both third and last on same node. Next, again continue, compare 8 and 4. Who is small? Second one is small. So now the steps are repeating. Watch this step. What I should do? Last next should point on this node. Okay. Last next should point on this node. And bring last on this node. Okay. Then move second to the next node. Second is moved on to the next node. So let us call just as for second. And make this last next as null. Now there are 2 nodes in this third linked list. This is the starting node and this is the next node. Then continue the same procedure. Compare first and second value. So this is smaller. So make this last next point on this node and move last on this node. I'll call it as just L. And move second to next node and make this as null. So now the procedure will be repeating. I will continue, but till here let us write on the code. So I'll bring back the things as it is and again show you the code. Now back to the same thing. What was the first step? First step is to check who is smaller, whether first one or second one. Whoever is smaller, bring 2 pointers, that is third and last on that node. So I will write down that code. If first data is less than second's data, then bring third as well as last upon first. That is bringing third and last upon the same node. We did this one. Then move first to next node. So take first to next node. First will move to next node. First should move to first next node. Then after that, this last next should be made as null. So last next is made as null. This is what we did for the first time. We did this with first linked list node because this was smaller. If suppose this was smaller, we would have done the same thing on this node. So I should write on inside else part for the second. Same steps, third and last should point on second. And second should move on to next node. Second should move on second's next node. And last next should be made as null. As we did upon first linked list nodes, we should do the same thing for second linked list also. So this is the initial step that we have to do. Then after this, we were doing repeating steps. What were the repeating steps? Compare the data of first and second, whichever is smaller. Now this is smaller. So make last next point on this one. This is one step. Then bring last on this node. This is the second step. Then if it is first or second, we don't know, whoever it may be, it should move to next node. Okay, second is moving to the next node. The next, make last next as null. These are the steps that we are doing. Let me repeat once again. Compare first data with second data, which is smaller, that is 8 and this is 7, so this is smaller. So make last next point on this node and bring last upon this node and move second to next node and make last as null. This is what we are doing. Again, I'll do one more time. Compare first data with the second's data. First data is smaller. So make last next point on this data and move last to that pointer, whether it is first or second. Then move first to next node. First is moved to next node. And last next should be made as null. This is what I have to do. Whoever's data is smaller. So again, I will write on the code here. If first data is less than second's data. This is a repeating part. So here we will be having loop, right? So this is a part of loop as we are going on repeating this one. So what should be the condition in loop? I will show you afterwards. But let us see this one. Now let us compare now. First data is a 10 and second's data is a 12, right? So that is smaller. So what I should do? Last next should point on first. Last next should point on first. Then last should be pointing upon first. I'll continue in the same line. Last should be same as first. Then move first to next node. Move first to next node. Move first to next node. How to move first to next node? First assign first caps next. Then make last next as null. Make last next as null. So I'll continue here only. Last next should be made as null. Lack of space, so I have written in a single line. You can see that these are the statements. This is one, then next statement, then next, and next. So total 1, 2, 3, 4. 4 steps I am performing if this is smaller, first is smaller. Otherwise, if second one is smaller, then for the second, same steps should be performed. So that is last next should be made to point on second. Then last should point on second. I'll complete the steps. Same step, just instead of first, it will be second. I have written same steps. If first data is small, do this. If second data is small, do this. Steps are same, only the pointers are different. Pointer is either first or pointer is either second. So this we have to go on doing it. So let me continue for some more time and see. Next, Compare the data. This one is smaller. 12 is smaller. So last next should be pointing on this one, and last should come here, and second should move on this one. I'll just write S, and last next should be null. Then again compare. First data 15, second's data 14. This is smaller. So last next should point here, and the last should point on this one, and the second should move to the next node. So the second becomes null, and the last null next should be made as null. Now I have finished all the elements in one of the linked lists, that is second linked list, and second linked list there are no elements because S became null, so I should stop. So it means this repetition I can do as long as there are some nodes in either first list or second list. If any one of the list ends, I should stop. Means if first becomes null or second become null, whoever becomes null, I should stop. So I should continue if both are not null. First should also be not null, second should also be not null. So while first not equal to null and second not equal to null. This is the condition. So I'll just highlight this condition. See, this is the condition. So as long as none of them is null, I should continue, right? So this is a loop. Loop is having these two things, like those 4 steps, either for the first node, first linked list, or for the second linked list. They are there. Now at last, what is remaining? See, one of the linked lists has finished and last is pointing on this node. Now there are some nodes remaining in first. So if there are some nodes remaining in first, then last of this one should point on first. That's all. Last next should point on first. If suppose there are nodes remaining in second linked list, then it should point on second. So here I will write down that part. If first is not null, after this loop, anyone is not null, right? Because one of them has become null, so it has came out. If first one is not null, then make last next as first. That's what I have done here. See, last is pointing on this one. Else, definitely second one will be not null. So last next should point on second. So wherever the nodes are remaining, it should point on that one. So this is the code for merging. The code is little lengthy. So if you see the third linked list, let me trace this one. Third, this gives the address of 2, 2 gives the address of 4, 4 gives the address of 7, 7 gives the address of 8, 8 gives the address of 10, 10 gives the address of 12, 12 is leading us to 14, 14 is leading us to 15, and after 15 there is null. So this has formed a one single linked list. That's all. This is merging. Now let us do some analysis. In analysis, there is no extra linked list required here. So that is the benefit of merging upon linked list. So you can say that merging is suitable for linked list because it doesn't require any extra space. In case of arrays, you need extra space. Then second thing is, what is the time taken by merge process? So if we say there are m elements in first linked list, then n elements in second linked list, so the time is theta of m plus n. This analysis we have already done in merging in an array. So you can watch that video if you want to know the analysis. Analysis is same here, m plus n. So whenever we say merging, we should mention the time as m plus n. So m are the number of elements in first linked list or n are the number of elements in the second linked list. Usually we don't take two variables, but to show that this is merging, we are making it as a notation for merging. So m plus n means, okay, this is merging. Merging is used here. So it has become a notation for merge. So that's all about merging two linked lists.